Hello viewers, welcome to today's learning. In my previous video, we have already learned theoretical concepts of replacement analysis and one first variety of problems on defender and challenger type. Today, let us see two more varieties of problems, that is problems on items which fail gradually and problems on items which fail suddenly. We have already seen in the last session that in an industrial scenario, equipment and machinery play very important role because for production they are directly involved and they have to be kept in good condition if one needs to run the business economically and efficiently. Replacement problems are decision making problems involving the replacement of existing machine that has already become obsolete or worn out with the best challenger available in the market. All the problems in replacement analysis can be classified into three varieties. First variety deals with defender and challenger type. Second variety with the items that fail gradually, and thirdly the items which fail suddenly. So let us see today first the items which deteriorate gradually. There are two types: when the value of money does not change with the time and when the value of money changes with the time. How do we identify given problem belongs to either this category or this category? If we go through the data and if I, interest rate I is given, then it belongs to second variety, that is money changes with the time. If I value is not mentioned, ROR, that is rate of return, or interest rate is not mentioned, then it belongs to the given problem belongs to first variety, money does not change with time. The procedure for both remains same, the methodology, major logic remains same, but when I is involved the problem becomes more complicated. So in real life, strictly speaking, we don't find this kind of problems. Value of money always changes with time, but still here we are considering just to understand the logic of the problem, because if I is not considered, problem becomes too simple. Just to understand the logic, simple problems are always better. So once we understand the logic, we'll apply the same methodology when I is involved. So 7 problems I solved in my previous video. We'll go to 8th problem. The cost of a machine is rupees 6100 and its scrap value is rupees 100. This is the first cost or purchase cost, and this is the resale value. The maintenance costs found from experience are given in the following table. O&M cost it is. When should the machine be replaced is the question. So let us move on. The data is still there. Years are given here and the period wise maintenance costs are given. So let us start solving this problem. Data is taken. P, the first cost is called as P, and S, salvage value, scrap value, resale value is considered as S. The formula to be used here is total cost in the bracket N. N represents life. So N can take any value like 1, 2, 3, 4 like that till 8. If N is 5, it's understood total cost for 5th year it is considered. N is 7, total cost for 7th year it is considered like that. P is the purchase price, salvage value. Salvage value also strictly speaking varies with the passage of time. So for at the end of first year it is one value, at the end of second year it is different like that. But in this particular problem nothing is mentioned like that. It's given scrap value is 100, so let us take it as constant. So we have to subtract salvage value from purchase cost, because purchase value is the cost incurred in purchasing the machine which goes out of the pocket for the owner of the organization, owner of the machine, one who buys the machine. Whereas salvage value, by scrapping it, he gets some amount to be subtracted from P because it is coming into the pocket. And maintenance costs are once again costs going out of the pocket, hence to be added, just like P it is. RN stands for maintenance cost. R is maintenance cost here, repair and maintenance actually. And N in the bracket, as I already mentioned, it represents the life, whether maintenance cost is for first year, for second year, like that. All should be added from 1 to N, however many years, for however many years it is given, should be added, and then we get the total cost for a particular life. Here one may question, how can we add the costs when they are happening at different time durations? Because I is not mentioned in this problem, the effect of I is neglected. Time value of money is not considered. So that is why money does not change with the time is the category under which this problem comes. That is why we can directly add like this. Otherwise, if once I is mentioned, then it is not possible to add like this. We have to go for calculation, the effect of I as well. Only in this exceptional type of problem we have this kind of addition subtraction directly, even if they incur at different periods of time. So now let us move on to second formula. If we get total cost, based on that we cannot decide. You need to get average total cost, that is A stands for average, total average cost, and once again N is life here. The value which you just obtained out of this formula, divide that by N, the period which you are considering, then you get average cost. So these formulae how to use, let us see through this problem. So this kind of table is needed. These table columns I have numbered so that it is easy for us to consider the calculations. For example, first column, second column, third column, fourth column, like that. So year N is taken. Here it is year, could be month, weeks, whatever. Whatever is given, we need to consider here. First column is year. This is maintenance cost. These two are nothing but data. Third, we have to add here salvage value, once again data. P minus S, once again data. TCN, as per this formula, we have to calculate here. So that is why 3 plus 4, 3 sigma Rn, and 4 is, 5 is P minus S. So 3 and 5, if you add, it is nothing but getting this formula. So 3 stands for P minus, sigma Rn, 5 stands for P minus S of N. So 5 is first part, third is second part. If you add 3 and 5, we will get sixth. But sixth will not give us answer. Sixth column answer has to be divided by first column. N, you know, N is we are getting out of here. So divide that by first column, you are going to get average cost. Then how to decide when to replace, I will just explain. Now let us move on. First year, we have to start from first year. Here it's given first year. Rn value, just copy this value. Sigma Rn, for the first value, this itself you copy. Sn is this value. P minus Sn is 6100 minus 100. So 6000. TCN is 3 plus 5, 100 plus 6000, 6100. And divide 6100 by first column value, we get this. Since it is 6100 itself. I would like to inform you here that in the exam you are supposed to show 2 to 3 specimen calculations. Here I have not shown, but for every row values, how did you get it? Wherever calculation is involved. For example, these two are data, fine. This though fine here. How do you get this? Show the specimen calculation. How do you get this? And how do you get this? Let us go to second year. Second year Rn value is 250, that is R2 250. You add now sigma, no? So add this to this, previous value to this new value, you get 350. This and this remains constant for this problem. If S varies, then this also varies. Simply subtract this value from P, which will be always constant. So you add 3 and 5, 350 plus 6000, 6350. Then divide that by this value, so you get 3175. Similarly, for the third year, R3 is 400. You can make out here 400. Add this previous value and this value, 750. then constant 6750 because 6000 plus 750, and then divide 6750 by 3, I first column value, sorry, not I, first column value. 6750 divided by 3 will give us 2250. Can you make out here first column value? Move on to next one. Fourth, n is equal to 4. Now you have to add, you have to pick the Rn value from here, then you have to add this to the previous value, you get 1350. These two values you have to pick from the data, S and P minus S, you will get you this. Then you add 5 and 3, you will get 7350, and you divide this by 4, you get this. So like this you just continue, no more explanation is needed. In the similar fashion we have to continue till all years calculations get over. Now 8th year calculation also got over, so we have all the values present here. Now how to decide when to replace? Question is when to replace. How to decide? To decide this, go to the last column. In the last column, just observe the values from the beginning. See the pattern, 6100, 3175. Second value is lesser than first. Third value is lesser than second. Fourth value is still lesser than third. So we can say values are continuously decreasing. How long? When it reaches this particular value, it has reached the least minimum value, and once again it is increasing. So catch that point where it is minimum. Corresponding to that, so I'll just show you. Catch the point where it is minimum. So it is this value which is minimum. Corresponding to that year is this one. So 6th year. So the answer should be, since TA, that is average total cost, is minimum for the 6th year, it is more economical to replace the machine at the end of 6th year, or end of 6th year is equal to beginning of 7th year. That is how you should write the conclusion. Conclusion has got dedicated 1 mark. So that is how you will solve the problem. So to summarize, it is just this formula to be used. Total cost is equal to first cost minus a salvage value, and add all the maintenance cost till that particular period. Do like this for all the periods, and at the end, in the last column, for every total cost you find the average cost by dividing that by the period value. So after calculating all this, you see observe the pattern. Wherever it is minimum, corresponding to that year should be considered. Here I would like to tell you one more point. Supposing if values are continuously increasing, for example 6100, 7200, 8300, 9500, 10800, like that, it's continuously increasing. So no question of coming down and then going up, but from the first value it's going up. For the given range, first value itself is minimum, so that first value should be the answer. If values are continuously increasing, if you don't find this kind of pattern, then the first value itself is the answer. Not here. Here we have the pattern. The curve is going like this and then like this. Supposing in a problem, if the curve continuously goes up like this, continuously up like this. Actually, the pattern should have been like this, reaching the minimum, then going up. Coming down is not there. If for a given problem, values are continuously increasing for the last column, then the first value itself you consider as the minimum. So shall we see in the same category one more problem? Following table gives, we'll see the table, running cost per year and resale price of a certain equipment whose purchase price is 5,000. P is 5,000. Determine optimum replacement policy. Year-wise periods are given from 1 to 8. Running cost is nothing but maintenance cost, that is Rn. Resale value is like this. What is the difference between this and previous problem? Previous problem, resale value was same, 100 rupees. Now the resale value differs from year to year. So that is why yes column, earlier we had all same values. Now we have to write the given values which are changing, and correspondingly calculations need to be done. Note that here let us not write S, let us write in the table itself because it is varying. Same formula to be applied, same column heading also, same table, no variation. First column, second column, can you make out for the second period 1600 is the running cost, add this and this, you get 3100. Then for salvage value for second year, pick from the table like this 2500. Can you make out they are different? Then P minus S, P is constant, 5000 minus 2500 is 2500. Similarly 5000 minus 3500 is 1500. Remaining it remains same, 2500 plus 3000, 5600, and then divide 5600 by 2, you get 2800. That's how you need to calculate all. And once all values are obtained, go to the, for all the 8 years actually we need to calculate. But if time doesn't permit, supposing, once if you see the pattern on the right column, in the last column, it's decreasing, got the minimum value, then once again it is increasing. If the time doesn't permit and if you stop at the 7th row itself, also will do. Sorry. So pick the minimum value 2700. Corresponding year is important here. So when to replace, this will give the answer at the end of 4th year, but you should give the justification. Why have you considered the answer 4th year? So since TA is minimum for the 4th year, it is more economical to replace the machine at the end of 4th year. So we'll see one more problem. There are two types of machines. Now there are two machines, not one machine, A and B. Purchase price for A is 7000, B is 9000. Resale value and running values are given separately for type A and type B. Can you make out? Resale values are differing. Okay. Determine optimum replacement for both machines and suggest which machine is preferred. The procedure what we learned just now, repeat it for both the machines. Machine A, I am not given the elaborated solution. You will come to know that 6th year you have the minimum and value is this much. And if you go to for machine B, it is 5th year and value is this much. Which one to select? Then you have to see the minimum value which you have picked, not the year, minimum value, that is TA for machine A is how much, machine B is how much, which is minimum out of these, machine A. So we will go for machine A out of this. Out of machine A and B, average cost is less for machine A and hence machine A is preferred. Now let us go to the next variety, when money changes with time. Now let us see a problem wherein I is given. A machine costs rupees 2,50,000 P value. Running and maintenance costs are 1,20,000 RN per year for first 5 years. This is a problem wherein table is not given. So in the text form it is given, we have to prepare the table. First 5 years it remains in 1,20,000, increase thereafter by 20,000 per year. 1,20,000 will become 1,40,000 for the 6th year, 1,60,000 for 7th year, like that. If the interest rate is 10%, once this percent rate of interest is given, it is understood. Second variety of problem methodology to be considered. This is bit complicated. Methodology remains same, logic remains same. Only thing is I effect has to be considered. But problem becomes bit lengthy and time consuming. So as soon as the problem on replacement policy is given, first you have to see it comes under which variety, whether defender challenger type, items failing gradually, items failing suddenly. Supposing if it is items failing gradually, once again you check whether I is given, I is not given. So if I not given, previous method whatever we adopted. If I is given, method remains same but laborious the steps, number of steps more. If there is no salvage value for the machine, take S equals 0, determine best period for replacing the machine. So no table, we have to form the table. P value, I already told you, 2,50,000, S is 0. Formula to be used. We will just compare. If I not given, we used this formula, right? Here, P minus S can be directly algebraically added, but here cannot be. There is a factor called capital recovery factor which will convert P and S put together into annuity. P and S put together into annuity. So it is called capital recovery factor. Make use of it here. P minus S into, after subtraction you have to multiply by this factor. This factor converts P, given P value, into A. So this should be P, and there is a proof, a small proof behind that procedure. How do we get this? So this is called capital recovery factor. Whereas here, this we get the value from the table, whereas here S into I has to be substituted after dividing by 100. If 10%, 10 by 100, 0.1. If 8%, 8 by 100, 0.08 into S. S is salvage value. Next is coming to RN. RN happens every year, like first year, second year, third year, fourth year, like that. And maybe same, may not be same, okay. So general procedure is given. What happens, since it is in getting incurred at various years, you cannot just add them. So when can you add? If you convert all of them into one particular value, I mean only to P, only to A, only to F, like that. Here we are converting all of them into A. Any replacement problem can be solved in two ways, either using present worth method or annual worth method. I have preferred annual worth method because if two or more alternatives are given and if unequal values, unequal durations are given, then annual worth method can be directly adopted. Present worth method needs a condition to be satisfied, that the assets co-terminate. This co-termination condition is not needed for annual worth method, so we are adopting annual worth method. Replacement problems can be conveniently solved also using present worth method. Answer remains same. And then finally the years by which the machine has to be replaced, it remains same. So now let us see how do we convert this Rn values for summation. So what are we doing here is, each Rn value separately we are considering as F, corresponding N is considered and will be converted into P. This particular factor will convert given F value into P. For the end of first year, if it is occurring, we are using N is equal to 1, considering that as F, converting into P. If we consider Rn, R2 occurring at the end of, for the second year, then N is taken as 2, then R2 becomes F, will be converted into P using this particular factor. Like that, all R values will be converted into P by considering the respective N values. So, this becomes, here small and capital N all are used in the with the same sense. So all Rn values got converted into P because of this square bracket. No, within this square bracket, whatever we get, this much from this square bracket till this square bracket, this will convert all Rn values into P. Okay, now we have all Rn values in the form of P. Can be comfortably added, so added. Summations stands for adding. All present value of Rn values are added. After adding, now we have cumulative Rn values in the present term. That flower bracket will give you that much from here to here. Now this P value can be converted into A comfortably using the factor A given P. This will convert given P value into A. Because this is A now, presently, multiply that by this factor to convert into A. What is N to be used now? N should be used the entire life, because A we needed for all the 5 years. So we have to consider 5. So that is how we'll be doing it. Let us see here. Now for the first column, let us see what are the column headings here. Once again, column numbers are given, so just to make out, so that can be conveniently used in the formula. First column as usual n value 1 2 3 4 like that, it varies till till the life is not given. If that is the case, no problem, life we don't need. When to stop question doesn't come. See the last column values when you get minimum, and if you are in a position to pick that minimum, you can just stop there. To know that it is minimum, you need to have after that one value at least. So now let us see first column for n rn. You don't go column wise, you go row wise, so that when to stop you will get the answer. Rn for first 5 years it is 1,20,000, so here it is 1,20,000 for first 5 years. Now p given fin, so Rn, every Rn value has to be multiplied by p given fin. Here capital N is equal to small n. Please remember, capital N for first column is 1, capital N for second column is 2, capital N is equal to small n is equal to 3 for the third row, like that it runs. Capital N is equal to small n. For the first row it is 1, for the second row it is 2, for the third row it is 3. So like that it runs. We will just write here that small n is equal to capital N. I'm not used to this kind of writing. This is taking a bit time. So small n is equal to capital N. Next is this factor value we have to get from the table, interest table. You go for 10%, go to 10% page. There n is equal to, for the first row it is 1, go to first row, under the column p given f, whatever value is there, pick and put here. Coming to fourth column, 2 into 3, just multiply this by this. So your Rn got converted into p. Every Rn got converted into p. So this square bracket thing is going on due to fourth column. Till fourth column you would have finished this much square bracket. Now it has to be summed up after this. So convert into p, then after, once all values are p, can be added. So go for summation of this, that is why summation of fourth. Coming to this, go to the table once again, corresponding to 10%, n value based on you are in which row. First row n is 1, second row n is 2, like that. Under a given p column, what value is there, pick and write here, because we already summed up. This flower bracket value has to be multiplied by a given p in. So corresponding value you pick from the table. Next you make this into this. All values got converted into a now. Till here. Supposing fourth row, if we consider till fourth year, all maintenance values, first year, second year, third year, fourth year, all got converted into a. Next, salvage value, you just write. In this case, it is a 0. There is no salvage value. Otherwise, you just record that. Next is this complete thing will be done in the 9th column. This is capital recovery factor actually. Capital recovery factor is one which converts given first cost and salvage value p and s into annuity. So p minus sn into 6 plus sn into I. P minus sn is fine. Why is this 6? 6 is nothing but a given p in. We already have, so no need to once again take it from the table. Make use of this which you already done it. So p minus sn into, first subtract and then multiply by this, that's what the formula says, plus si, and n is 1 2 3 based on the row number. Next is 7th and 9th. 7th and 9th you add, you get the final column. See the pattern of values, wherever minimum value is there, pick it. Corresponding year you say is for replacement. So let us see. First year Rn you pick from this 1,20,000. P given f is from the table, you can just check. For 10%, for n is equal to 1, p given f is this value. This into this, you get this. Then sum it up. So first value as it is. From the table once again pick this 10%, n is equal to 1, a given p value. Multiply this and this, you get this. Then salvage value record from the table, from the question, given data 0. And then you make this specimen calculation you have to show, 2 or 3 you have to show. P minus Sn means 2,50,000 minus 0 into 1.1 plus 0 into 0.1. So this term vanishes because salvage value is 0. That's the advantage. So you get this. Now you add this and this, you get this much. Similarly, we will see one more instance of calculation for the second period, that is n is equal to 2. Once again, Rn value from the data given, then P given F In from the table. For I is equal to 10%, n is equal to 2, you get P given F from the table this much. This into this, you get this. Then you add, that means this plus this, you get this. This value plus this, you get this. Similarly, this plus this will give you this value, like that. This is from the table. 10% n is equal to 2, a given P will give you this value. Now you multiply this and this, these two you multiply, you get this. Salvage value from the data 0. Do this calculation. 2,50,000 minus 0 into this value 6, this value, and this term vanishes, otherwise should have been 0 into 0.1. So you get this much. You add 7th and 9th, these two, to get this value. Simply you remember this, then you include the I effect. So third row, similarly, this remains same. This is from the table for third row 10%, and this is this into this summation. These two you have to add, you get this. Then this from the table 10% for the third row, 5th and 6th, you get this. Salvage value 0. Do this calculation using this one, and if you add 7th and 9th, you get this. Similarly, the same thing goes on. 6th row, when we come, we have to add 20,000 to the maintenance cost. Don't forget. Remaining things remain same. 7th, 8th. How long we have to continue? Nothing is given in the problem. Only first 5 years maintenance remains this much, then it increases. That is all it is given. What is to be done? Keep observing these values. When you get minimum, how do you come to know it is minimum? It keeps decreasing. At a particular point, it reaches the least value, then it starts increasing. When you get one value after increment, you can stop there. 179, 177. Next is 178. It got increased. You can stop here. You can bold this as the required value. Corresponding life is 7 years. So write the conclusion. EAC is least at the end of 7 years. So replace the machine at the end of 7th year. So I repeat, how do we get this formula? It is nothing but the same formula which we used, but with I effect. P minus S is purchase minus salvage value, should be converted into annuity. Use capital recovery factor. Next, this complete formula has got two parts. This is for P and S, and this is for maintenance. So for P and S, capital recovery factor. For maintenance costs, every year it is happening, so you cannot convert all of them into P by considering each one of them separately as F using the corresponding N value. N will be 1 for the first row, N will be 2 for the second row, like that. So get this and multiply this, get this value from the table, multiply to the corresponding Rn. This getting that, you just add them to the previous values, so you get summation of that. For example, for the third period, this value will give all the maintenance costs being added up after conversion, after considering I effect. You cannot just add 1.2, 1.2, 1.2 like that. You have to convert them into P, then you have to add. So this will give you these three. Suppose if you take n is equal to 6, this will give you summation of all maintenance costs after conversion. But this is still P. P cannot be added to CRC. So CRC is annuity. So this also should be converted into A, then should be added. So sum it, then you convert that into A, then you add it to this. So we'll move on to next problem. Next I have given as assignment. Let us move on to replacement policy for items which fail suddenly. For example, bulb, resistor, ICs, etc. They do not deteriorate with time. over a period of time, if efficiency decreases, you can make out, for example, your vehicle, if you consider the mileage keeps decreasing, you can make out it needs to be serviced. But here, these items, they don't uh, give any indication. For example, bulb, if you consider, whenever you switch on, it will be lit, it will be illuminated. But one fine day when you switch it on, you will come to know that no longer it will be lit, it cannot be illuminated. Then you understand that it has failed. But in an industrial scenario, such situations, when for components of the machine, if it happens, then the production gets hampered. So to prevent it, we are going for preventive maintenance. How? Understanding the behavior of such tiny items. Those are actually tiny items, but many in an industrial scenario will be in large number used. So what to do? Its behavior is a bit tricky. We cannot study it. So then we cannot, by observing we don't get it. So what to do? We do past data. From the past cost data, we derive the probability distribution. Using that probability distribution, we try to solve and we will analyze economic life of it. So not possible to predict the time of failure. Any moment it may fail. Today new bulb we have got, tomorrow it may fail. After 1 month it may fail. After 1 year it may fail. After 5 years it may fail. We don't know. RP stands for replacement policy, is determined based on probability distribution of failure of items obtained from past data. You have the past data about that item. You extract the probability distribution, apply it for the current and future items. Once again, there are two types: individual replacement policy, IRP let us call, group replacement policy, GRP or GRIR. IR stands for individual replacement policy, GRP for group replacement policy. So here what happens is, supposing group replacement policy says, okay, all the resistors have to be replaced yearly once, 12 monthly once. But there is every chance that soon after the first month or during the first month, few of the resistors will fail. Unpredictable, their lives are unpredictable. During second month, some of the bulbs may fail, resistors may fail. Third month, some more may fail. Some may not fail only. So then what to do? Though 12 monthly once you have to replace all the resistors, say 1000 or 10,000, however many are there in the company, at once you are replacing, fine. In between, as and when they fail, you have to replace them individually according to IRP, individual replacement policy. As and when, for example, in the first month, if 5 resistors fail, those 5 you have to replace as per IRP, individual replacement policy. Second month, 3 failed as per IRP. But group replacement has to take place only 12 monthly once in this example. So group replacement policy has got clearly two parts of costs. First part is due to individual replacement, second part is due to group replacement. So we have used a few symbols here. N is total number of items. Previously it was period. Here it is total number of items. Depends on what type of problem you are solving. So here capital N is total number of items. I stands for the period. NI means N for first year, N for second year, like that. Number of items replaced during ith period. For during third period, if it is N3, fourth period N4, like that. CI, once again, C3 means cost of individual replacement. That is cost of individual replacement. Here I doesn't stand for period, I is for individual replacement, G is for group replacement. So CG is cost of group replacement. These two are different because this is wholesale price. If you are purchasing 1000 bulbs together and if you are purchasing 1 or 2, then the costs differ. So two separate costs. P stands for probability of failure during the given period. I is given period. K is life, means K can take only one value. K is 8 means I will take 0, 1, 2, 3, 4 like that till 8. So period I, this will be given as data. 0, 1, 2 like that till k. K is supposing 8. I already told you 0, 1, 2, 3, 4, 5, 6 like that. This is continuation till k. Probability of failure in period I, P0, P1, P2. This is the probability of failure in the second period, probability of failure in the third period like that till probability of failure in the kth period. So let us see how exactly individual replacement will be done. IR. First we calculate expected life. How do we calculate expected life? Summation of I into Pi. Here itself it is 1 into P1 plus 2 into P2 plus 3 into P3 like that up to K into Pk. Can you make out I is equal to 1 to K? First you multiply, then you add. Average number of failures per period is equal to n by expected life. Supposing n is 1000, 1000 by this answer. This will give you some answer that should come as the denominator. N is given the data. Average cost of, that's all, only two steps. Average cost of individual replacement per period is average number of failures per period into Ci. Means here whatever answer you get into Ci. Ci is one value. It is cost, no, it is not connected to I, it is individual replacement cost. Only three steps we will get the answer for individual replacement. How about group replacement? All items are replaced collectively at once after a specific period of time, irrespective of whether they have failed or not. I told you, for example, 12 monthly ones, all ones you replace, all the 1000, if there are 1000, all 1000. But in between the things, items which fail, you have to replace them immediately and individually. That is why group replacement cost has got clearly two parts. Once again, same notation I have just copied so that in every slide it will be there, it becomes easier. This will be given data. Now how to proceed with group replacement? Individual replacement we just saw, now group replacement. First you have to calculate, because we have to see for individual replacement how many get failed every month. First month how many failed, second month how many failed, so that those many into Ci will give you individual replacement cost, part of group replacement. I already mentioned group replacement has got two parts. One is group replacement cost, the other one is individual replacement cost. Reason is, supposing the duration which you have considered is 12 months, there is every chance that every month, once the usage starts, at any time the item may get failed. So that's why you need to have individual, that items which fail other than the group replacement duration, that is other than at the end of 12 months, at the end of, during first month, during second month, during third month, all of them should be replaced individually and immediately. That cost is called individual replacement cost under group replacement. So how do we calculate that n? Ni, I is period here. N1 is equal to N0 into P1. N0 is nothing but N, okay? Initially the total number of items which are present. That into probability of failure in the first duration. Because how many fail in the first duration? Probability of failure in the first duration into total number of bulbs. How many will fail in the second duration? Say for example, let us consider month, second month. It has got two parts. Why, you know? Second month, when it comes, some of the bulbs, if there are 1000 in the beginning, out of them some you would have replaced in the first month. Which one you will replace in the first month? Those which failed in the first month. So the bulbs which you replaced in the first month, for such bulbs second duration will be the first duration. Listen carefully. The bulbs which you replaced in the first month, for example 1000 bulbs are there, in the first month 5 got failed, those 5 you replaced, though for those 5 second month will be the first month because they got replaced in the first month. Whereas remaining 995 which didn't fail, were not replaced, they are not fresh for the second month, for them it is second period running, second month running. So N0 into P2, N0 is nothing but N. So for the new items, they will fail according to 995 will fail according to probability distribution of second month failure, whereas N1 represents the one which you replaced here. which you replaced in the first month. For them, second month is first month because they got replaced in the first month. So they will fail according to probability distribution of failure of the first month. That is why like this. Similarly, when we go for the third one, there are three parts. The bulbs which were not replaced, for them it is third month. Bulbs which were replaced in the first month, for them it is second month. Bulbs which were replaced in the second month, this answer, for them it is the first month. Corresponding probability distribution they follow. Similarly, N4, 4 parts. The bulbs which were not replaced at all, for example, here 5, here 10, here 15 got replaced. When you come here, it will be 5 plus 10, 15, 15 plus 15, 30. Supposing totally there are 100, 100 minus 30, 70 70 are fresh for the fourth. 70 are not fresh for the fourth duration. They were not replaced at all. They will fail according to probability distribution of fourth duration. Bulbs which you replaced here 5, for them it is third month, so according to third month distribution. Bulbs which you replaced here 10, for them this is the second month. Bulbs which you replaced here 15, for them it is first month, so accordingly they will fail. Now how to remember them? Logic behind them is one part. How to remember them is in the other part. While writing the exam, those kinds of tricks and tips will help you out. I will just tell you, if you carefully observe these, they follow a pattern. Can you make out? See, all of these formulae start with N naught. Can you make out? All of them will start with N naught. That's why N naught is introduced. Actually, N itself would have been enough. But just to remember the formula, N naught is introduced. N naught. Every time you start with N naught, P should have the suffix corresponding to this 2 here. If it is 3, 3 here. If it is 4, 4 here. Further in the next step, N suffix should continuously increase like this. N suffix should continuously increase like this. Next term will be N4, N5 like that. And P term should have the first suffix equal to this. 1 itself, you have to stop at P1 because we don't have P0. In the 0th period, none of them will fail. Here it is given, but none of them will fail. It's understood. So you have to stop at P1. Any formula, if you consider, you have to stop at P1. Any formula will start with N naught, it should end at P1. Once if it is reached P1, you have to stop. That is one indication when to stop. Second indication is that N2 should have 2 terms, N3 should have 3 terms, N4 should have 4 terms, like that. Within N5, N6, you get the answer. Next is P suffix, if you observe, it keeps decreasing. See, 3, 2, 1, 4, 3, 2, 1. So I repeat with the last formula, you have to, each one of the terms will be the product of 2 terms, N and P. N4 means there will be 4 terms, N3 means there will be 3 terms, like that. All formula will start with N naught. All have to end when you write P1. And N should have the suffix naught, it should keep increasing. P should have the suffix equal to this N suffix. If it is 4, this is 4. If this is 3, this is 3, like that. If it is 5, this is 5, like that. Keeps decreasing. And when to stop the formula? When you reach P1. I hope you understood how to remember. Now these are the column headings. Different table now. Period I. GR cost means group replacement cost. IR cost you don't get directly. Individual replacement cost you don't get directly. You have to get first the numbers. How many you are replacing? For example, in the first month, only one number. Second month, N1 plus N2. Third month, N1 plus N2 plus N3. Third month means till third month, however many you replaced. All have to be added. IR cost, once you get this number, into N I will give you. Sorry, into C I will give you this. Total GR cost is just add this and this. This will be the one. And average cost will be this divided by I, as usual. I have not written column number. If you want, you can write so that it becomes easier. So let us see. First period. Group replacement cost remains same. See, all columns it remains same. It is just N into CG. Total number of items into group replacement cost. This is also unique for a given problem. This is also unique for a given problem. Just multiply, you get. N1 is the number of bulbs which you replaced in the first duration, first month, because N is equal to 1. Can you make out here N1 plus N2? Because Till second month, how many you replaced individually? However many got failed in the first month plus how many got failed in the current, that second month. How do you get the third one? Third month means so far all cumulative. So N1 plus this, or it is previous value plus this value N3. N4 will be, we'll see later. You just multiply this by CI. This is CG, group replacement cost, wholesale cost. This is retail cost. This whatever value you get into CI. Next you add this and this, you get this. Next you divide this whatever value obtained by I, you get this. So I'll go for second column. This remains, I've already told you. Here you want to know cumulative how many you replaced, how many items got replaced. So N2 whatever you have plus N1. From where do you get N1 and N2? From these calculations. Next IR cost, this into CI. You add this and this, you get this. You divide this by 2, you get this. Similarly 3. Now you have till third period. How many you replaced? You replaced N1 in the first duration, N2 in the second month, N3 in the third month. You add all of them. Or else to this value you add N3, you get this. To this you multiply by CI, individual cost, you get this. You add this and this, you get this total GR, this by this. This is actually not total this is average, it's written here, correct. Next, optimal GR period is the period corresponding to minimum average cost. You see the cost here, their pattern. Pick the minimum, corresponding duration is the group replacement duration. So let us solve a problem. The monthly mortality rate means death rate, so nothing but failure rate, have been observed from a certain type of light bulbs. So 1, 2, 3, 4, 5 weeks, here weekly bulbs failure data is given. Percentage of bulbs failing by the end of the week. When the problem is on items failing suddenly, seeing this data, these words, reading again and again is very, very important, because based on these words, data given, based on the data given, you have to analyze. The procedure differs, few steps you have to do extra. So keenly observe percentage of bulbs failing. This is very important, failing. Percentage of bulbs failing by the end. This is also very important. By the end, failing percentage. Though it's given percentage, it's not given with the decimal point, it's given as number. So it's understood 10%, 25%, 50%. Okay. But it is not during first month 10%, fine. During second month not 25. Till second month it is 25%. Till third month it is 50%. Means it is inclusive of failure that took place in the first month plus second month plus third month. Or it is 25 plus however many failed in the third month. In the percentage you have to add to get 50. How do we identify? The last number says that. Or you see the pattern, if it is continuously increasing, it's understood it is in the cumulative fashion given. Sometimes they don't give like that. So see the data, is it continuously increasing? Then it's like that. There are totally 1000 bulbs. Capital N is equal to 1000. It costs ₹2 to replace an individual bulb. Retail price CI is ₹2. If all the bulbs are replaced simultaneously, group replacement cost 50 paise, 0.50 rupees. Otherwise also greater one will be retail price, that is CI, smaller one will be wholesale price CG. Just see the difference, how much it is. It is proposed to replace all bulbs at fixed intervals whether or not they have burnt out, and to continue replacing burnt out bulbs as they fail. At what intervals should all the bulbs be replaced? Group replacement policy itself is like that. Key, all bulbs will be replaced at once at the end of the group replacement duration. But as and when bulbs fail before that, then individually and immediately will be replaced. For example, we'll see this example solve. Let us then analyze. Solution. N is equal to 1000. I already told you. This is this. N naught is also N, 1000. N naught means in 0th period, how many you replaced? In 0th period, usage would not have started. So no replacement. CI is individual cost. Out of these two, whichever is maximum. It's understood, or else the words will tell you. Group replacement cost, wholesale price. IR stands for individual replacement. So let us see how to do. There are only 3 steps, I suppose you remember. So this is the data given. I have written as it is, percentage of bulbs failing by the end of the week. But for our calculation, okay, I have divided, because it should be written in percentage, I have just divided by 100. Can you make out? Third row, first row, second row, third row. How did I get the third row? This calculation says. Third row, how do you get? Corresponding second row divided by 100. For example, if you want this corresponding second row element value, divide by 100. If you want this corresponding second row element, divide by 100. If you want this corresponding second row element, divide by 100. That's the meaning. Second row means corresponding second row element. That's how you get. Just divide by 100 and write. Probability of failure during the week. Probability, percentage both remain same. Okay. If percentage is given, you can take it as probability. If probability is given, you can take it as percent. We don't need any percentage, we need probability. Then why these values are changing compared to the given values? I want during the week. Very, very important. I want during the week. Okay. Not by the end of the week. I want during the week. There is difference between during the week and by the end of week. Okay. So I want during the week. How to get during the week? This is 1, 2, 3, 4. Fourth row calculation, let us see. Corresponding third row minus previous element in the third row. If I want 0.15, supposing, okay, fourth row element value I want. Go to corresponding third row element minus previous element. 0.25 minus 0.1 will give you this. If I want this corresponding previous element minus corresponding previous row element, 0.5 minus previous row and previous to this element, 0.25. 0.5 minus 0.25, 0.25. If I want this corresponding previous row element, 0.8 minus previous element in that row itself, 0.5. 0.8 minus 0.5, 0.2, like that. So first one you take it as 0. At the end of the first duration, it is corresponding value minus previous value, 0.1 itself. Corresponding value minus previous value, like that. If you want this, this minus this. If I want this, 1 minus 0.8, point. Formula is here. So now just I have copied the same thing for more clarity. In one slide, if all are present, becomes easier. Now, in between rows, I have just cut because I need more space here. And how did we get this? I have already explained in the previous slide. Now we have got the output of that, outcome of that step. So I have written here. Expected life, here k is equal to 5. This 5 will come here. K is equal to 5. I into pi means 1 into 0.1. So let us see how to add this. It is 1 into 0.1 plus 2 into 0.15 plus 3 into 0.25, like that it runs. So when you do this calculation, you get 3.35. Because it is given in week, let us write here weeks. Average number of failures in each week, n divided by expected life. N is 1000. Expected life is 3.35. You get 299. Those many numbers. So bulbs. Average cost of individual replacement per period. So of course this is per week, 299 bulbs per week. But we don't want in number of bulbs, we want cost. So average number of failures per period, that is this answer, into CI, that is individual replacement cost, 2, we get rupees 598 per week. This value we will just carry to the next slide for more clarity while comparing. So let us move on. Question I have just repeated for clarity. Till here it is the previous value which I have carried. We got 598 previously. Now let us see individual replacement cost we got, that calculation got over. Group replacement cost, let us find out. Now once again I repeat, this has got two parts. One is group replacement cost, the other one individual replacement cost. To calculate individual replacement cost, we have to consider individual replacement numbers. For that N0, N1, N2, N3, like that we have to calculate. So we'll see. To calculate Ni, N1 is equal to N naught into P1. N naught is 1000, P1 is 0.1. From here we get 100. That's how we get N1. N2 should have two terms, start with N naught, end should end with P1. P should have, first P should have suffix equal to this, it keeps reducing. This I will not explain again and again. Just will substitute. N naught is 1000, P2 we get from the second period probability 0.15 plus N1, just you got the answer 100, and P1 is 0.1 first period probability. So you get 160. Similarly, N3, N naught into P3, P3 is 0.25, N naught is 1000, 1000 into 0.25 plus N1 into P2, N1 you got here 100 into P2, 0.15 plus N2 into P1, 160 into 0.1, 281. Like that you calculate. N4 you get 377, N5 350. How far you have to go, I will tell you in the next slide as and when we come to that point. This I have added now, all these values only, they are listed in this table. Okay, number of replacements made, replacement of bulb made at the end of ith week. 0th week no replacement because no failure. First week 100 got replaced, second week 160 got replaced, third week 281 got replaced. These many bulbs got replaced as per individual scheme. That means in the first period itself 100 got replaced, 100 got failed. Actually group replacement duration is, say for example, if it is 4 weeks, bulbs we don't know, unpredictable, in the first week itself they may fail. So I have carried the things once again to the next slide like this. Directly I have written this value. This is the outcome of the previous slide, and this is previous to previous slide. We calculated IR cost to be compared now with the group cost. Once again, group replacement calculation, let us continue. If we just get the numbers, it is not enough. Let us see what is the cost of it. So this already I explained. We'll see how the calculations go. First period, N into CG, this remains same for all the rows. Okay, N is 1000, CG is 0.5. This remains constant. So 1000 into 0.5, both remain constant for all kinds of problems. So 500. N1 you pick from this table, 100. N1 into CI, CI is 2. 2 into 100, 200. Now you add this 500 and 200. You divide this 700 by 1, you get this. We'll see one more instance of calculation. I told you this is same. Here now you have to see for the second row how much is the failure, 160. You have to add that to 100 to get 260. That 260 into 2, because till second period how many you replaced? 260 into 2, 520. You add that 520 and 500, you get 1020. Divide that by this value, you get 510. Similarly, third one, this remains same. Now you have to add N1 plus N2 plus N3. That means previous value 260 plus N3. N3 you pick from this table, 281. So 260 plus 281, it will be 541. 541 into 2082, and 1082 plus 500, 1582. Divide by this value, you get 527. So we need to go for one more slide. So same way, N4 is added to previous value, 541 plus 377. These are NI values, number of replacement made. Okay, so I will just write this for your reference. These are nothing but N value, NI value. Means this gives N1, N2, N3, N4 like that. But we want here cumulative, all previous values will be added. For the fourth week, I want how many bulbs we replaced from the first week. So you add all of them, multiply by CI. Similarly, you add this and this, you get this, divide this by 4, you get this. Now see the pattern, it keeps reducing reached minimum, then again started increasing. Pick this for group replacement. Number of periods to be considered is 2. Suppose all values are continuously increasing, pick the first value itself. For every week you have to replace. That's the meaning. So let us write the conclusion. When you do conclusion, if you just pick this value, it is not enough. You compare with this. So compared to individual replacement, group replacement is less. So let us go for group replacement period 2 weeks. Individual replacement cost per week is 598. Minimum group replacement cost per week is 510. So prefer GRP once in 2 weeks. Sometimes they ask when individual replacement is more preferable. Consider the first week value 700, 598, which is minimum. So if at all you are considering the first week, then you go for individual replacement. Don't go for group replacement. If you are considering only 1 week, go for individual replacement. But second week, if you consider the complete life, if you consider, go for every 2 week once replacement. Now we will see one more problem. Here probability of failure directly given. Can you make out? In the previous problem it was given as the whole number. Now it is given as fractional number. How to identify whether it is cumulative values given? That means fifth week probability means inclusive of all first 4 weeks probability. Is it like that, or every week probability separately given? How to identify? I told in the previous class, if whole numbers are given, the last value should be equal to the total number. If in percentage, if it is given, last value if it is 1 and all previous values are continuously increasing, then cumulative is given. If the values are not continuously increasing, somewhere there are exceptional values, then it's understood it is not cumulative, it is corresponding week probabilities given. But once it so happened in the exam they stopped here, this was not given, they stopped till here, 6th duration, 1 2 3 4 5 6, they stopped here, and it was continuously increasing, but there were only 4 values. Students just mistook it. Always remember, before starting the problem, when this kind of problem is given, you have to add all and you have to check whether it is 1. Supposing if this is not given, 0.0 plus 0.18 plus 0.29 plus 0.46 plus 0.68 plus 0.92. I'm sorry, when individual values are given, this kind of addition is needed. When you add all of them individually if they are given, and if you are not getting 1, it's understood 1 value is missing. So here though you can make out 1 is there, so none of the values are missing. This kind of cumulative values when given, such situations don't arise. I'll tell you when, as and when it comes in next problem it is there. So let us take the only thing here compared to previous problem difference is already probability is given, percentage is given by dividing 100, but still cumulative are given. Cumulative values we are not supposed to continue. Problem needs PI, probability occur in that particular week only, we need to separate them out. So what is that we are doing? CI we picked, CG we picked, fine, N we picked, IR is probability, this is copied from the data, but one more step is needed. What is that? Probability of failure to date. This is not to date, during that period. Probability of failure, just make the correction, during that week. This is PI, nothing but PI this is PI, not up to date. Okay, not, this is not correct, it is only during that particular week. So PI. Now how do we get it? I already showed you the calculation. So it is 0.18 minus 0.04 will give you this, 0.29 minus 0.18 will give you this, 0.46 minus 0.29 will give you this, like this. Can you make out the values are not continuously increasing? 0.04, 0.14, fine, it increased, then again decreased, increased, 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 decreased. So these kinds of values are given as data. You can make out directly values, PI values are given. If cumulative values are given like this, then PI are not given, you are supposed to calculate one step extra. How do you identify? Values are continuously increasing, number one. Last value is 1. Or else sometimes in number, if they give, whole number if they give, last value is 100. Just like previous problem, last value was 100. And when these values are given, you have to first check. Supposing if this is the data given and last value is not given, till only sixth one it is given, then you add this 0.04 plus 0.14 plus 0.11 plus 0.17 plus 0.22 plus 0.24. You will come to know it is 0.92. So that is why this is complete data is not given. So 0.08 is the last week you add, and you the difference after adding all this, if it is not 1, however much difference is there, you add it. Now expected life, you get like this. How we have done 1 into 0.04 plus 2 into 0.14 plus 3 into 0.11, like that you get 4.43 weeks. You have to just divide 100 by 4.43, you get 22.6, because bulbs should be whole number, I made it 23. So average cost is 23 into 2.35, you get 54.05 per week. Next, let us see how the group replacement calculations go. I already explained. N1 you get 4, and N0 is 100, 100 into 0.014. This is PI actually, and PI and this is I. So 1 into 0.04, 2 into 0.14, 3 into 0.11, like that. So when you do N0 into P1, you get this, N2 like that similarly. So next step would be go for period, total GR cost. I have not shown the split ups, like the calculations is stepwise, I haven't shown. It's up to you. So when you complete the calculation, as soon as you get this, you can stop, because it was continuously decreasing. It reached a minimum, then again it is increasing. So conclusion is that prefer GR once in corresponding to this 3 weeks. Average cost per year is 45.39, and in case of individual cost it is 54.04. So which is better? This is better. First month also, first month it is individual is better. Second month onwards group is better. Sometimes they ask preferably for the first, when individual replacement is preferred, like that. So we will see now. Two problems are given here. You have been asked to compare. Just compare these two problems. What is the difference? Both are similar problems. 1,000, 2 rupees, 50 paise, everything. We have already seen this problem. But see here how the numbers are given. See here how the numbers are given. It is not continuously increasing. Increased, 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 decreased. Then you first immediately add them. 15, 25, 50, 80, 100. Fine. If when you added, if you get 80, then you add one more period 6. 100 minus 80 is 20. You make it 20. Like that. If probability is given, you will get 0.8. Then you add 0.2 for the 6th month. 1 minus cumulative of this. After addition, however much you get, that you subtract from 1. Whereas here it is cumulative. How can you identify? Continuously increasing. Last number is 100, which is equal to this. I mean, last number is 100 because it is percentage it is given. So last number is 100, and in terms of 0.1, 0.25 they give, last number will be 1. You can make out. So this is very important to see whether cumulative values are given or PI itself is given. This is PI, but this is not PI. One more step is needed, like 10, 15, 25 minus 10, 50 minus 25, like that. This you see, it's not given in percentage, but it is given in number, and total number is 1,000. And what is the other difference? Very, very important difference. Bulbs in operation means quite opposite to failure. Failure, if it is, see for example, operation in 0 means no replacement, all 1000 are operation. First month, 850 are operating. How many then got failed? 150. We are not interested in those who are surviving. We are interested in the failed bulbs. So we need to calculate one more extra step. So how do we get it? This is CI and this is CG. I'm sorry. Uh, yeah, this is CI, this is CG. Now, what is the next step? Bulbs failed by the end of the week. We have bulbs in operation by the end of the week. This is by small mistake by the end of the week. How do we do? Calculation is given. Third row. This is third row. First, second, third row. 1000 minus corresponding element in the second row. 1000 minus 850, 150. 1000 minus 400, 600. If total bulbs is 10,000, correspondingly you have to subtract from 10,000. Previous problem it was given as 100, no? Irrespective of the number given here, it was in terms of percentage and 100 was considered. Total number of bulbs available, 100 was considered only for this data. Then you have to subtract from 100. You have to see that based on data you have to consider. It doesn't always depend on number. Sometimes they give the number, sometimes they consider 100 as the base. Next row, how do we calculate? Fourth row, bulbs failed during the week. This is the cumulative. By the end of the second week, 600 got failed. By the end of the third week, 800 got failed. But during the third week, how many got failed? So this is nothing but number of bulbs failed during that week. So you just go for that calculation. Corresponding third row minus previous element. If I want this, corresponding third row minus previous. 600 minus 150, 450. If I want this, 800 minus 600, 200. If I want this, 1000 minus 800, 200, like that. So probability of bulbs failed during the week. Fifth row, fourth row divided by 1000. 150 by 1000, 0.15, 0.45, 200 by 1000, 0.2, 200 by 1000, 0.2. It is not like this. When you add this, you should get 1. It is not like this. You are dividing by 100 because this is not based on 100 numbers are given. Base is not 100, base is 1000. So very carefully you have to divide and put there. You see this problem. Percentage surviving operation all are same, opposite to failure. A computer contains how many resistors? 10,000. When any one of the resistors fails, it is replaced. Cost of replacing single, that is retail price is 1, whereas wholesale price is 35 paisa. Surviving is given means you have to find out failure. We are not interested in the surviving because survived resistors we are not replacing. So 0th year 100, first year 97. 97 resistors are surviving means how many failed? 3. By the end of second week, by the end of the month, it is not week, month, surviving. So it is continuously decreasing. If it is surviving, continuously decreasing, then it's understood cumulative given. So what should we do? The pattern is quite opposite to failure. Items failed by the end of the week. Not surviving end. Just subtract from 100. Third row, 100 minus corresponding element in the second row. 100 minus 97 will give you 3. 100 minus 90 will give you 10. 100 minus 70 will give you 30. Why 100 minus we are doing, though total number of bulbs is 10,000? Like in the previous problem we subtracted from total number of bulbs. Now we are not subtracting from total number of resistors because given data, for given data base is 100. That's why 100. For given data, if total number is base, then you subtract from total number, like previous problem. It was 850, 800, like that. This is base is 100. So 100 minus correspond, 100 minus 97, 100 minus 90. But we don't want failed by the end of the week. We want during the week. So corresponding third row minus previous. 10 minus 3 will give us 7. 30 minus 10 will give us 20. So item failed during the week. So I'll just correct this. Not by the end of the week, it is during the week. during the week. Next is, we will move on. Percentage probability both are same. Failure during the week, once again, okay, not by the end of the week, during the week. So just divide this by 100. Can you make out 4th row divided by 100? Why are we not dividing by 10,000? Because the data is based on 100. So pi, this is nothing but pi, okay, this is nothing but pi. We got this pi here. If probability of failure itself is given, that subtraction question doesn't come. If probability of operation or surviving is given, we have to go for subtraction. If cumulative is given, we have to go for subtraction. If individual values are given, subtraction is not needed, like that, based on the type of data. Now here, just compare these two problems. In this problem, it's given 10,000 bulbs, data is based on 100. For this data, 100 is the base. Here 1000 bulbs are given. For the given data, once again 1000 is the base. So that's why here, when we get, after subtracting from 1000 and after converting cumulative into individual values, we are dividing by 1000 because values are based on 1000. Here surviving is given once again, so we convert that into failure by subtracting from 100. Here we subtract from 1000, here from 100. Then we convert into individual values, then we divide by 100, here we divide by 1000. So based on the type of given data, you have to do the calculation. So these are the problems I have given as assignment. These problems you try on your own, and along with the problems which I already solved in this video, all put together, and I'll give some more questions also on replacement analysis. So all put together, you submit the assignment. Thank you for your patience hearing. We have come to the end of this video. Thank you.